On this episode of Garage Science, we're going to look at Newton's second law, and that deals with acceleration. Acceleration depends on the object's mass and on the net force acting on the object. And here's the formula Newton figured out. And if you notice, there's a direct relationship between acceleration and net force, and an indirect relationship between mass and acceleration. Okay? So for instance, if mass is held constant of the same object, okay, acceleration and force change in the same way. So if you increase the force, you increase acceleration. And if you decrease the force, you decrease acceleration. Now there's one interpretation, but many applications. Let's go outside and take a look at this, and then we'll come back in and discuss it further. Bob and I are here today to talk about Newton's second law. And we have some very simple demonstration to show you. The first one consists of this box full of bubble wrap. Why do we use bubble wrap? See, this egg looks very concerned, but has no reason to be, because why? See? Absolutely perfect. But what if we take the box away? I'll show you that in a minute. I have to move Bob for reasons. Bob, I said you were going to move. You just went from one side to the other. You're the same exact distance. Never mind. I don't even try to figure this out. Okay, so watch this one, Bob. Take a look here. Make sure you're looking at this. Here we go. Ready? And... Oh, not the same outcome. Okay, we're going to take care of this. Exactly. Why were the two outcomes different for the two eggs? Well, the first egg landed on bubble wrap. Bubble wrap is this in a real form. It's the application of that part of the formula. See, when the egg hits the bubble wrap, the acceleration is over a period of time, and so the acceleration is less, so the force is less, so the shell can handle it. But if that egg lands on something hard like the tabletop with a sidewalk out there, I don't want you rolling away there, guy. Could happen again. In that case, the acceleration happens over a very short time, so very large acceleration, and the force is large enough that it overcomes the shell. Now, that egg isn't the only thing that can be scrambled if it hits something solid like that or comes to an abrupt stop. Your brain can too. In all seriousness, how do we protect you? Well, we don't rub you in, or wrap you in bubble wrap. What we do is we put your head inside of something that acts like the bubble wrap. Say, for instance, a bicycle helmet. It's got this foam in there to do exactly the same thing as the bubble wrap did for the egg. Okay? Or it may be something like the suspension system inside my helmet. That suspension system, something hits you there, that slows the acceleration down, slows the force down, and your brain might just make it out. Okay? There's all kinds of helmets like that. Okay? All right. Let's go take a look at one of the other laws. Bob, put down the bubble wrap. I see what you're doing. Stop that. Bob and I are here. Oh, that's hard on the knees. Bob and I are here with a new friend, Mr. Floppy Wings. He's a little dragonfly, and he's going to help us review Newton's second law. So, here's a grill, here's a bug. They meet quite often. This little bug's going to fly in here, and it lands here, do what bugs do, just kind of sit there and be happy. Why can he do that and not be harmed? Well, because when he flies in and he lands, the acceleration, now you might want to call it deceleration, but it's actually acceleration in a negative direction. I'm just going to call it acceleration. Is over a long period of time, actually, and so acceleration is low, so the force is low. So therefore his legs can handle it. And he flies away all happy and all that kind of thing. Well, let's say Mrs. Knapp is driving, say, through Perdix, and she's doing 40, it's a 35-mile-an-hour zone, but it's still Mrs. Knapp. Okay, so anyway, now the bug meets the grill. Okay, different outcome. All right, now, why this time is it such a not so good thing for the poor little bug? Okay? Well, because since the car is going rapidly, then the acceleration is great. And the force is humongous. And the exoskeleton of this poor little creature can't handle it. And so it becomes, in the words of the scientists, bug splat. Okay? So, what's the difference between being shooed away and being sprayed away? Newton's second law. Thank you. All right. I'm going to show you one more thing about a car that will help you so you don't become bug splat. Okay? Take a look at this. Bob here has been bugging me about taking him out for more driving lessons. I told him once the booster seat gets here and he can actually see out over the dashboard, we might just do that. But in the meantime, we've been talking about how Newton's second law keeps us safe in the car. He has his lap belt on and his shoulder harness. That works really well. And there's also a second thing here. See the SRS, Supplemental Restraining System. That's the airbag. And up there you can see the curtain airbag. What do these things do? Well, when they deploy, it's like having giant bubble wrap around you. Okay? So what really happens is the acceleration, because you hit the airbag and it slows you down over a longer period of time, that goes down. And if that goes down, the force goes down and you don't become human splat on the dashboard. So let's hear it for Newton. All right, Bob. Maybe later. All right. Here we are back at Newton's second law again, and we're looking at the formula. In this situation, we're saying acceleration and mass are inversely proportional. As the one goes up, the other one goes down. So, if you hold the force constant, acceleration and mass change in opposite ways. If the mass goes up, acceleration goes down. If mass goes down, then acceleration goes up. Well, let's go outside and take a look at that. I know we're bouncing back and forth, but it seems to work. Lots of fun, Bob, bouncing back. Never mind. Bob and I came out here to the Clarksgrave Bridge to help you understand a little bit more about Newton's second law. That if you put the same amount of force times two different size mass objects, the acceleration will be greater for the smaller object. Now, I thought this would be a lot of fun because you could see where the balls hit. But, you know, Bob said, Bob, what if you hit a fisherman? Well, what if we can't get the ball back because it's in Maryland? And then he said, and this is what changed my mind, what if we accidentally hit the last remaining narwhal in Ferry County? I'd feel horrible, all right? If I bumped one of them on the head. So we're going to go off somewhere else and find another place to do this. Oh yeah, this is going to be fun. These guys are going to get some distance. This is the where the Appalachian Trail and the power line goes across each other, and that's Halifax over there. You ready, Bob? See which one goes the farthest? What do you mean we could hit I'm not going to hit Halifax. Oh, you mean a hiker? That is the Appalachian Trail. Yeah. What do you... There are no narwhals up here. Oh yeah, there's bald eagles. What if we accidentally hit a bald eagle? That would look good in a Duncannon record. Local teacher arrested for hitting bald eagle with a golf ball. Yeah, you're right. That wouldn't look good. All right. Let's go find somewhere else. You're taking all the fun out of this, Bob. Oh, why is the ground so far down there? We are here at first base at Wheeler Field in Duncannon. And look, Bob, no narwhals, no nothing. And we got a nice scientific setup here. We just have to sacrifice a bat, whatever. Now, so we're going to take all three. We added a softball just for grins and giggles. And we're going to hit each one and see which one goes the farthest. According to Newton's second law, the one that weighs the least should go the farthest. Well, let's just see if that holds true here in Duncannon. All right, so I'm going to pick this up, let this go, and the ball goes. Look at that thing roll. Amazing. Okay, now I have to readjust this. Ugh. Alright, got to readjust it so that the ball hits, just barely misses. There you go. Raise that up just a smidgen, smidgen. Okay. Raise it up just a smidgen. Okay, here we go. And we'll bring this back up to the same level. My knees are killing me. And look at that. Look. Oh, it's going so much farther. Oh, man. All right, let's try this one. Gotta make it smaller, so the hole's smaller. Okay, got that. That's gotta hit it just right. Raise it up. Dippity. Dippity-dippity-doo. Oh, too high. I'm allowed to hit it. Alright. See if we can hit it square. That'd be a nice change. And here we go. And oh, look at that. Look at that roll. Can you see that? Whoa, it's out of sight. There you go, Bob. Newton was right. Same force, different mass. Smaller mass has got more acceleration. It's going to go farther. Yeah. All right. Yeah, things are working. We're back inside here to take a look at why that demonstration worked. Once we finally found a location where we weren't going to hurt or harm any endangered species in Perry County, Newton's second law, if the force is held constant, now that baseball bat was held constant, same height, same swing, same everything. The only thing that was different was the mass. We had 3 different masses of balls. Now, as the mass went up, the acceleration went down. The heaviest one went the least distance. As the mass went down, the acceleration went up. The one with the least mass went the farthest. Okay? That's a direct application of Newton's second law. Another one you're familiar with, probably didn't even know it was Newton's laws. If you're ever on a bus, school bus, and there's not many kids on there, that thing can accelerate pretty fast. You know, like drive you back in your seats, that kind of thing. But if you've got every seat filled, and you've got every kid you can cram in there, you know, and it starts off, you know, you can be passed by turtles or sloths or things like that because it's got so much weight in there, so much mass in there, it's hard for that engine to get it to move. All right. Ponder that for a while. That's the end of episode on Newton's second law. See you next time. Here we have an egg, and here we have a sheep. According to Newton's second law, if this egg hits this sheep, and the sheep slows down its acceleration, because it's over a longer period of time, the force will go down also, proportionally, and therefore the egg won't break. It's a good theory. I'm okay because it's not me being thrown against there, but the egg, on the other hand, it's got some concerns. So let's just try this. Look at that. It worked. Let me throw it a little harder. Yeah, woohoo. I like when things work. Yeah, it's fine. What do you mean, Bob, you don't think it's a real egg? It's a real egg, Bob. Look. See? It's a real egg, right? Fast acceleration, high force, the egg can't take it. Slow acceleration, slows down, force goes down, the egg can take it. Bob, when are you going to start believing me? It's okay to be a skeptic, but come on, have a little faith, would you?